Okay, let's start with this. A peak element is an element that is greater than its neighbors. So, okay, for any elements, the previous it will be greater than the previous and next element. Given an input array in nums, where nums I is not equal to nums of I plus 1. Okay, the element is not same as next, but that will also hold for the previous element. So then, if duplicate elements have to appear, then they'll have at least some other element in between. They are never gonna be like consecutive in nature. Find a peak element and return its index. A peak element. You don't have to find many peak elements. Peak element is element that is greater than its neighbors. Okay. Okay. The array may contain. Now we don't need to find index of this. So of course we can sort things here. But then we can do this in O of n. So sorting doesn't make much sense. Maybe we can see what are the values or the ranges of nums. Anyway, so find a peak element and return its index. The array may contain multiple peaks. In that case, return the index to any one of the peaks is fine. So we have to return an index in this case. And we can imagine that nums of -1 is minus infinity. Okay, so 1, 2, 3. So 1 is higher than this, but not higher than 2. 2 is higher here, but not higher here. 3 is higher on both the sides, so 3 becomes our peak element. Your solution should be logarithmic complexity. Nice. Makes sense, man. O of n, anyone will be able to do this. So now how do we achieve logarithmic? So there are only two things. I still have to think this out, but one way is if you had it sorted, you could apply binary search, right? Second is you divide it into two groups and find peak element in each, right? And I think we can always assume that there will be at least one peak in the element, right? I think that's expected, because even in the example they don't give an example where they are just returning -1. So now let's try to think if we can apply the first approach wherein we are doing binary search. What will binary search do? We'll try to compare first and last, the middle element, if middle element is a peak element or not. If it's not, what would that mean? So if mid element is not peak, does that imply something? Then that means that on one side of it, if it's not peak, then that means either on the left side or on the right side there is one element which is greater than this element. Now does that imply anything? If on the right side there's an element which is greater than this element, and on the left side there's an element which is smaller than this element, still don't see how we can solve it through that, but let's just think a little more deeper. Like maybe on the right side, does this imply that if you're able to not find a peak element at one place, then it's going to be on the left side or right side? Why would this be? What if we just divide into two groups and keep doing that? uh, so we'll divide into 1 2 1 3 and 5 6 4. Then we're going to divide into 1 2 and 1 3 and 5 and 6 4. That's not making sense either. Plus it's using extra space there. It's some kind of binary search thing only, but we still have to think how will this imply, like if we are not able to find, if middle element is peak, then we are sorted. If it's not peak, it can be in both areas. Now how can it be in just one area? So say we are given this kind of an example, right? Now 3 is not peak here, obviously, because it's higher than 1 but lower than this. And that means if we move on the right side only, then we are gonna check for say 6. Actually, we'll say we check for 5. Do we always keep going on the side where we find the higher element? Why would that make sense? Because what if this had been like something like 7? So this is 5 and this is 8 and this is 10. This is 7. So I'm not able to find something. So if this is 3 and I want to not move on the right side, then that would mean that I need to not have a peak here, right? But that becomes somewhat impossible, because if 5 exists here, then not having a peak means that the next number should be lesser than 5, right? Or if it's greater than 5, sorry, it has to be greater than 5. If it's less than 5, then 5 will become the peak element, so this will become greater. Now if this also has to be not a peak element, then the next element also has to be greater than it, because otherwise we'll face a problem. So then this will have to be higher than 8, which is at least 9, and if this becomes 9 and it's greater than this, then this becomes a peak element. Got it? So binary search it is. We're going to code the binary search here. Let's try. I usually make some silly mistakes, but I'll try not to do that today. So we're going to have a left starting at 0, right starting at len of nums -1. These are indexes, while we're going to keep going while left is less than equal to right, and mid will be left plus right divided by 2. Now once you have divided, you have a middle index. You're going to check if r of mid is greater than r of mid -1 and r of mid is greater than r of mid plus 1. First of all, for that mid has to be, yeah, mid will be something, but mid plus 1 may not exist, right? So okay, so maybe this needs to be max of mid -1 and 0, or wait, if mid is equal to 0, right, we won't have a mid -1. So in that case, the condition just becomes if r of mid greater than r of mid plus 1, and if mid is equal to len of nums -1, then we won't have mid plus 1. So r of mid needs to be just greater than r of mid -1. If we can do this case, okay, return mid, return mid, return mid. Is not these cases and R of mid is less than R of mid plus 1, then we can change low to mid, or not low, left to mid plus 1, and that's all. And if R of mid less than R of mid minus 1, then we can change right to mid. Right. And this, based on this, will come to an element which is like this, else we can return minus 1. Probably we should do a dry run. Even though this probably might be an easy question, we should do a dry run here. So 1, 2, 1, 3 is 5, 6, 4. Left is 0, right is length of now 3, 4, 5, 6, 7, 7. So 6. And this is 0. This is 6. While left is not equal to right, or left is less than equal to right. While 0 will go inside 0 plus 6 by 2, which becomes 3. And mid is 3, 0, 1, 2, 3, so that becomes a 3 element. If mid is 0, mid is not 0, mid is not that also. R of mid is greater than mid minus 1, yes, but it's not greater than mid plus 1. Okay, then R of mid is less than R of mid plus 1, yes it is. So left becomes mid plus 1, which is 0, 1, 2, 3, 4. Right stays as 6. 4 is equal to 6. 4 plus 6, 10 divided by 2, 5, 5. 0, 1, 2, 3, 4, 5. So it gets to 6. Sixth element, like this element which is 6, is gonna check if 6 is the answer. 6 will actually be the answer, so it's just gonna return it. What happens with 1, 2, 3, 1? 0 and 3. So left and right becomes 0 and 3. And then 0 plus 3 by 2 is going to give us 3 by 2, which is 1. So 1, this will become mid. Now it's going to check is this is the answer. No, it's not the answer. So it's going to, left will become 2, right is going to become 3. 2 plus 3, 5. 5 divided by 2 is 2. So mid will also be 3. It's going to check 3 will be the answer. It's going to return that. So this seems okay to me. This should be able to find the answer. If not nums, return minus 1, I guess. And if len of nums equal to 1, then return nums of 0. So that's another edge case, that if it's just one length, that is the answer. If it's two length, then our logic can sort it properly. Some small issue in the syntax. R, oh my god. In between I changed it to R. Some places I've used R, some places I've used nums. This is just when you're coding and you forget the variable name altogether because you're too used to doing this DSA algorithms every day and using R as the array. variable name. So nums, we're gonna check every line how we should do it. Nums. I hope I've not changed left to low and high also, right to high. Left, right, left, right, left, right, right, left, right. Okay, mid is also mid. Oh, now things seem fine. Let's see if it runs. See if it gets submitted. Wow. I'm expected to return the index. Sorry. Oh, it's a median problem. Oh, 87 and 96. It's quite good. Cool. Let's meet in the next video. If you guys like this video, do hit a subscribe button. I'm gonna keep publishing this until I get really good at all this. It's helping me also, I think, and so yeah. I hope this helps you. I hope the entire thought process maybe makes it easier for you, because I somebody helped me during this. I had seen a YouTube video which helped me, and I was like, hey, this can help other people and this can make it easier for me also during this entire COVID time where you have to kind of speak in your interviews. So yeah, cool guys, see you in the next video. Bye bye.